Okay, so start at the top so I could show you guys the neural network I created for my dataset. Right in here, I just imported some of these packages, and then I imported my dataset as well. I have the bank dataset, and so this is what it looks like. And then I did do some data analysis and visualization, as you can see. I think this one is the most useful. Well, these, and overall, we see that most people have secondary education, and then after that, they have tertiary education, and then there's the least amount of people are the ones that have the primary education. And that seems to be the trend overall. Let's see. And then over here, we're just creating our data frame that's gonna have just age, balance, date, and education, because I decided to use those three as our independent variables, and the dependent variables education. And then I went ahead and used the label encoder to make education numeric. And then over here I did it so that it could be more of an array. So we end up with this little sparse matrix over here. And then if we look, so if it has 1, then that means it's primary. And the one with education 0 fills in with 1 means that it's secondary. And then tertiary is education 2. And then I'm pretty sure if it has education 3, that means it's unknown. And then we also want to scale all of our independent variables. That's what I went ahead and did right here. And then this is when we're setting our training set and our test set. As you can see, our test set is 34% as it was specified to do so right here. So I went ahead and did that. Test size equal to 0.34. And then I went ahead and created the neural network model. So that was just this step right here. And then we did the X train, the Y train with the model. And it did the default of our iterations. The default is 200, but since you can see right here, it didn't change in the last 10, so it just ended the iteration at 160. And our accuracy score is 5.683, so about 5.1, which is only decent when you're considering that's only accurate about half the time, slightly more than half the time. And then what I found here from my confusion matrix is that the model overly predicted how many times people were going to have a secondary education, and that's that one right here. As you could see, this is the predicted, and we could see in the predicted column that we predicted a lot of times that they were going to have a secondary education, when in reality they either had a tertiary education or a primary education. So that was that. And then the ones over here, that is, like I said, secondary education. So as you can see, more often than not, it predicted that it was going to be secondary education just about all the time. The model has a very high recall for secondary education, as you see here by the 0.94. Very low for the tertiary education. And then over here we see that the F1 score is also very low for the tertiary education, and overall the precision is equally divided for all of the secondary, primary, or tertiary education. So all of the education levels are more or less the same. We see secondary is a little bit higher, but then tertiary and primary are not that much lower in that case. Then I just went ahead and summarize this in my words. So those are the 5 sentences. And then over here, so step 2 asked me to tune the predictions to set the results approach the quality of the random forest run that I had. So if we go back to my random forest, that was right over here, we see that we have accuracy score of 0.044, and then I achieved something very close to that, 0.4 3 if you just see right there. And then I also got a similar looking confusion matrix. I know the numbers are a lot higher for my yellow tab, but if you just compare the color from the confusion matrix of the forest model versus the neural network model, we see that it'll be like this yellow is for the predicted one, and then we have this lighter green and then the darker is all on the right hand side, and that is the same here. The lighter color is just in these cells, and overall they have very similar colors, even if the numbers are a bit off. And if we go to the classification report, we'll find, oops, wrong tab, we'll find that precision has, for the primary is 0.21, and ours is 19, and then for secondary is 0.51, and ours is 0.53, and then for the other one, for tertiary is 3.6 for the forest, and then for our current model for the network is 0.34. And then recall is 13, 64, 32, 17, 64, 30. So very, very close all around. I mean, same goes for F1 score and 16 score. And the F1 score for the random forest versus our neural network. So it's 16, 57, 34. This is 18, 57, 32. So very similar results to that. And I got the similar results by changing the hidden layer size to 20 and the max iteration to only 3. So then this actually, and we ended up having a larger error here. Yeah, and then for the third one, I have, it asked to run the multiple logistic regression, considering the gradient descent to see if you can improve the quality. So I went ahead over here and I made, this model taking into consideration the gradient descent. I don't really know how I was supposed to take, a regression came into this, because as you could see, I put our model in here and it said that it has no object of OLS. So wasn't totally sure about that. And yeah, so this is my model.